Hey y'all, this is Lauren Malone, and now we are going to talk about interpreting confidence levels and intervals for AP statistics. Let's get started. Okay, so I'm going to go over an example problem and walk y'all through it step by step. A baseball coach was curious about the true mean speed of fastball pitches in his league. The coach recorded the speed in kilometers per hour of each fastball in a random sample of 100 pitches and constructed a 95% confidence interval for the mean speed. The resulting interval was 110 to 120. Okay, a couple of things that we should notice about this problem is that it says a true mean speed. So it's a sample. This is one sample z-test probably. The coach already did it. In some problems we are going to have to find the interval ourselves, but in this situation we are just interpreting what is given to us already. Okay, also that the confidence level is 95% and the confidence interval is 110 to 120 kilometers per hour. Okay, so the first question is, what is the confidence level? And interpret the confidence level. And I'm going to give y'all the answer and then I'm going to explain it. So, this is the confidence level interpreted. If the coach repeats this process many times, then about 95% of the resulting confidence intervals will contain the true mean speed of fastball pitches in his league. Okay. When writing a confidence level interpretation, there's 3 to 4 things that are very important to include. And the first thing is stating that you're going to repeat this test, this trial, this process many times or multiple times. Because if you just do it once, it's variable. And it could be that unlucky chance that it just so happens to not be the parameter of interest doesn't have to be within the resulting confidence interval, which is possible because it's not 100%. It's only 95%. So if you do this multiple times, your results are going to be more precise, and then you're going to be able to get a better conclusion over the test. Okay, so if the coach repeats this process many times, check. So many times, check. Then about 95% of the resulting confidence intervals, we stated the confidence level, and we said of the resulting confidence intervals. It's not of the resulting data. It's specifically the intervals will contain. That's important because we're trying to obtain the confidence interval, or we have obtained the confidence interval, and that's what the test was for. Okay, will contain the true mean speed, not just the mean speed, the true mean speed of fastball pitches in his league. And this is of the whole population, not the population, but the entire, all of his pitches is what it's talking about. It's not just talking about of the sample. So it's important not to say of fastball pitches in his league of the sample, in his league total, and it's talking about the entire league. Okay. The next question is interpret the confidence interval. So the confidence interval is 110 and 120 miles per hour. But how do we say that? Okay. We are 95% confident that the true mean speed of fastball pitches in the coach's league is between 110 and 120 kilometers per hour. It is important to say that we are blank percent confident when writing this interpretation. So we definitely need to restate the confidence level in here. The next thing that's important to say is that the true mean speed, not just the true speed, it's the mean speed because it's the average of all of the data that he recorded. Okay. And a fastball pitches in the coach's league, so that gives us context, which is important. And then at the end, it is, important to restate what the confidence interval is. It is between 110 and 120 kilometers per hour. For our last question, how will increasing the confidence level from 95% to 99% affect the confidence interval? So we're becoming more confident. And if we're more confident, that means the margin of error will increase. We're making it easier on ourselves. Right now, we're 95% confidence it's within this range, but we're even more confident it's within this range because we're giving ourselves more room for error. This is just kind of like a visual view of a larger margin of error. So our answer is increasing the confidence interval will increase the margin of error, resulting in a wider interval. So specifically, an example of a wider interval would be maybe 100 to 130 kilometers per hour. If we say that was our interval, we do definitely feel more confident it's somewhere in there because it's more likely. Okay, thank y'all for watching.